Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below. Now, let's begin. Hi, today we are going to know about how to estimate the problem with no decimals after them. So which means the problem will have a direct result of an integral. So remember I have done a problem like this. So we given a function, not a function, I mean an equation of this. And we are going to find a. How are we going to find this? So in this case, we are able to do a brief calculation to see what 10th degree is here. So we know this must be a 10th degree. I mean it must have can only have, I think, at most 2 digits. So we are going to calculate this. 1, 0, 0, 0, 0, 0, 0, 8, 9, 10, 11. Okay, so from here we know it is larger than 10. And we are going to calculate if it's... So we know that this is going to be 20,048. So in this case, you times this by 20,048 and you will get this, which exceeds this value. So we know it has a range of 10 to 20. So we are now going to analyze the second digit. How we are going to analyze? You should know that the last digit can affect. For example, if the last digit is 1 and you power it by 1, you will get the result of 1. If it powers by 2, you will also get 1. If it powers by 3, you will also get 1. Okay. You can find that 1 and 5 both share the same common thing. And also we are going to, so we can use this way to write the last digit of every number, starting on 2. So we are going to examine whether the result is going to be, the unit digit is going to be 2. So we can try. If it is 2, then the expected last digit should be 2. If it's power of 2, it should be having an expected digit of 4. Similar expect digit of 8. Expect digit of last digit of 6. And you can find 5 and 6 and 7 and 8 are rotation of them, respectively. So we know the last digit is not going to be 2. Now we try 3 to think whether 3 will work. You can find that 3 actually work when it adds a power of 3. So we can find that 4, it will have a final digit of 1, and 5 will repeat 1, 6 will repeat 2, 7 will repeat 3, respectively. So, and you can find since 7 repeats 2, and you will find 11 also repeats 7. Okay, so you can find that it works. But you need to calculate whether other digits may apply. For example, 4 won't if you calculate like this. Hmm, 16, yes. So this is the rotation of 4. of last digit. 5 I already say, and this is the rotation of 6. For the rotation of 7, you can find that this and this are all going to have a last digit of 7. But if you use an educated guess, you can know that this won't be true. You know that since this is an exponential function, and this is, if you, just like if you, even though if you consider it as linear, or here, if you want to consider it as linear, but it's actually wrong. So, we know that 11, 12, 13, 14, which they have, we know that this we're going to have a difference of 20,048, times. So we guess this is 20,048x, which is x. So in this case, since you know how exponential function is like this, you can just draw a few lines, and you will find that 7 will much exceeding this. Because it's only 2 times, and it is 2408 times, so it's 17 will definitely go over it. So 8 won't be. So, but I'm still going to show the rotation of 8s, which is 64, 55, 102, and 6. This is rotation of 8. And the rotation of 9, we're going to have a repeating consistently rotation of this. So in this case, we are going to successfully prove that we get this correct. And we are able to write A is equals to 13. Prove our final answer that this is correct. Smile. So this is a way of calculating it, like by using the final digit. We can make an... And by the way, if the problem is very simple like this, you can just calculate it directly. But sometimes you won't have a calculator beside you. So this is a way of calculating the number that the equation that lasts with an integer. And it is the end of our story today. See you tomorrow. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!